You're on. Go ahead.
No, it's not.
Oh, you don't. Oh, wait.
It's my first day back.
Hold on. Need this one. This one. You might need that one, I guess. Yeah. These are the two immediate ones. We're going to work on this one.
Can I take it?
Oh, sure. There it is. All right. So we can see what's happening. Sweet. All right. Everybody's got their Z-score chart, right? You do now? Okay, good. She's blood red. Yeah. Raw. All right, let me grab my Z-score chart. Alright, so I'm going to do the first few semi-quickly. If you weren't here, you should probably go see the video, or come see me, or do something to be nice to yourself. So, just to remind you guys, we knew empirical rule before now. Half of his attention. We knew the empirical rule before now. This just kind of is a way to expand on that. So, if I calculate a z-score for somebody, they aren't necessarily going to be right at 1, 2, or 3, and that's the only thing we knew with the empirical rule. Not good enough. So I want to be able to tell how far out can I go to catch 92% of the people, between what two heights would 92% of all men be between? That's an interesting question to know. How tall should I make the door? Well, it depends on what percentage of men I want to have to duck. Right, we can just make it 10 foot tall. That's crazy. Just to make sure that if we all start getting even taller, that we can still fit through the door. But let's not go crazy. So the whole idea, plus we had that idea I was trying to really develop, that the area under the curve is the probability. As long as the total area is, what would the total area under that curve have to be? 1. Because that area represents all the probabilities in a normal curve, so the total area must be 1. The sum of all the probabilities is 1. So we saw a uniform distribution had little rectangle areas. I can calculate those areas, and that's the probability. Easy as shit, right? Rectangles, beautiful. This shape, normal curve, oh crap. I need a lot of help, because it's not a shape that I know anything about. Right? What's the perimeter of that? You don't know. What's the area under the curve? Well, we can look it up. If you know calculus, you could maybe do it if you knew the formula. Even then, you couldn't, because it's not integrable. But for those of us who did not take calculus, who don't want to go to calculus, let's just live in this world. We have somebody have done this for us. If I know the z-score, 1.51, and I look it up in the chart, I always find the area that's below that z-score. So if I look at 1.51, it's going to tell me the area below, and that's exactly the area that I want. I want the probability z less than this. So I want to look at 1.51. So this is z-scores. It's got to be a normal curve. 1.51. This is 1.50. It's a real easy mistake to make. 1.50, 1.51, and we got 0.9345. I like it. You guys remember that? You guys see what you wrote down before? Wow. There we go. The difference between that one and this one is, one thing is it's negative 0.44, so it's going to be down here. And out the area above it, the chart doesn't have a damn clue the question that I'm asking on this. When you look up negative 0.44, you will always find the area below. There's negative 0.401234, negative 0.44. That second decimal place is defined by the column. The first decimal place is defined in the row. So 0.3300. Where is that on my picture? 0.3300. Where is that going to be on my picture? Yeah, below that negative 0.44. Why does that make sense? I mean, I haven't got the answer yet. But above 0 is what percentage is above 0? Because the mean does what to the picture? It cuts it in. So above 0 there is what percent? 50. So I know the answer's got to be more than freaking 50, because I'm even further back going up. I've picked up some area between 0.44 and 0, right? So that being the answer doesn't make a damn bit of sense. So I know some of you guys are like, good job, Jeff, you got the wrong end. No. Now what do I do with that number? Yeah, 1 minus. I want the other side. I want the rest of it. And we know how opposite probabilities react. 1 minus 1 is the other one. So this would be 1 minus 0.33, which is 0.67. So there's a 67% chance. If the grades on the last test were normally distributed in here, I have a 67% chance to get somebody who had a z-score of more than negative 0.44. That's how I can interpret that physically. All right, let me let that settle in. I really want to make this point. This has got immediate, practical, real-life applications. It's a relatively simple idea. Calculations aren't very extreme, but this stuff is going to rule our life for several weeks. Many. I like it. Some of you guys should be happy, because this is not too bad. It's going to get a little freakier today. Because let me ask you, let's get to the next, get to number 4, number 4 of 2. Part C, how the hell do I do this shit here? Negative 3.21, positive 1.98. I want the area between those two. If I look up 1.98, how is that related to the answer? Is it too much, too little?
Too much.
Too much. It's exactly this much too much. You guys see that? So of course I take this, which is too much, and I subtract this, and I end up with the answer I want. But you have to find the areas. It's the areas that I want to subtract, right? Don't subtract those numbers. That won't mean crap. You'll be somewhere else entirely. So what do you get when you look at 1.98? What area do you guys find here? 1.9. Yeah, 1.98.9761. Right now, make absolutely certain that you see how I got that. You have to let me know if you don't see, because you're going to be using the hell out of this chart. Alright. Everybody's either sees it or doesn't want to let me know. Okay. 9761. I like it. So that's 0.9761, but that's too much. I got to look up negative 3.21 so I can see how much I have to subtract off. When you look at negative 321, what do you get? 0.0007. Real quick, do you see how little this is changing down here? Do you see how little it's changing? Why does that relate? How does that relate to the picture? I'm down here, it's not changing by very much, whereas here, it's changing by quite a bit. Do you guys see that? Yeah, the curve is way flat. It's not changing by very much. Here, it's changing by a lot. That's the freaking slope I'm talking about now, right? Slope is way big in here. Back here, it's pretty small. It's close to 0. How important is that for you to be able to do problems? Not at all. But it's just a feature of this, that the more it makes sense to you about what that is, the more you understand this. So what did we get? I'm sorry, I forgot. 3.007. Right, 0007. I like it. And now you just do what with these areas? Subtract it. I like it. To get the area in between. I like it. So let that make complete physical sense. 0.9761 minus 0.0007 is 0.9751. How are we doing there? We cool? Alright.
So that's the answer?
Oh, yeah. So the question says, what's the probability that I get between them? And in our case, probability is the same thing as finding the area. So we found the area that relates to that region. We're done. I love the incredulity in the voice, whoever has talked to me. I don't think I've ever used the word incredulity. I feel, ooh, look at me go. The disbelief is the other way to say that, right? Like, that can't be it. That can't be. Yeah, that's it. That's all that problem wants. Going from z-scores to probabilities should always be relatively easy, because that's the purpose of this thing. I've got all the answers just sitting there waiting for me. Sometimes I got to do 1 minus because it's the other side. Sometimes I got to subtract 2 areas because I want the middle. But it should not be difficult at all. Things get difficult when I don't start with z-scores and when I have some other weirdness happening. We're going to get into that today. This one gave us some trouble because we forgot what the hell this means. Well, what the hell does that mean? 33rd percentile, which means it's 33% where? Below it. Which means that's why you would hate to be there. You don't want to be this person on a test, but you do want to be that person on a golf range. Right? This means 33% got below you. Which means 67% got above you. So on a test, bad. In the golf score, in the golf place, good. I don't play golf. Listen to me. In a golf place. Sorry. So my little brother bowls, and I don't bowl at all. So I'll go, you got to go play bowling? He's like, you say go bowling. Yeah, whatever. Throw the ball, whatever. So this will, how much is this? Yes.
Go from the side up.
So 0.33. I really want to make this point. Do not write that. You have to identify that as what it is. That is an area, right? That's the 33rd percentile. That's a percentage. That's not a z-score. If you put it down below, it looks like a z-score. You look up 0.33. You do all this work, 0.33, you get a bullshit answer. Because it's not a z-score. Areas look like z-scores, those evil things. So put areas up here. So then you say, oh, I don't know the z-score yet. So where do I look that up? Where are areas on the chart?
Inside.
Inside. Is z-scores on the outside? Areas on the inside? Some of you guys figured out that this is exactly related to part B. Let's pretend like we forgot that. If you find 0.33, it's right there. And then you can look out to see negative 0.44. That's the z-score. So if I give you an area below a z-score, you can look it up to see what that z-score is. So what does this chart do? If you know the z-score, you can change it into a percentage. If you know the percentage, you can change it back into a z-score. That's what this chart does. It's just this chart's job. I like it. Cool? So what again? We got negative 0.44, which again relates to this problem up there. I gave you negative 0.44 and you looked up 0.33. We just did that in reverse. If I know the area, I can look back out to see the z-score. Part E is the same kind of problem, except now I'm saying 5% above it. So where's that going to be? Where? Yeah, it can't be down here because that would have a huge percentage above it. I need to have just a little 5% above it. Will my chart understand that area? No, because the chart only gives me or understands areas that are... It only understands areas that are where? Below the z-score.
Thank you. Whale speak.
And this would be how much?
Can you help us?
0.95. Cool. Do you guys understand why I had to do that? Again, the more comfortable you are with the shortcut I showed you and all that kind of stuff, you can use it in multiple places. If you don't quite get the shortcut, never use it. Never. Sort of like related to blinkers. If you don't use them all the time, never use them, because you're the people that have it blinking this way, and then you go that way. It sounds like an old man, but okay. So let's see, 0.95. If I look up 0.95, am I going to look at the positive or negative z-scores? Positive, because it's up here. 0.95. I get right in between these two, and the little asterisk that give me the answer is 1.645, because it's right in between 1.64 and 1.65. That's amazing. So it's 1.645. So that's the z-score that has 5% above it in a normal curve. Coolness. Alright, I think we did a couple of these, right? We did the first one? So what goes right in the middle on this one? I kept putting 0 in the middle up here because these were all z-scores. And for z-score, the mean is going to be 0. Because the mean is right on top of itself, 0 away from itself. What's going to be in the middle here? 31.64, that's the mean. And I want to know the probability less than 27.2. So where's 27.2 go? Over here, yeah, please understand. I know you probably don't. I know you know where it goes, but sometimes you just plop it somewhere without even thinking about it. It's the number line. It's got to go down here. And I want less than that. Now, can I look up 27.2 in the chart? Because the chart, I can only look up what on the chart? Yeah, the name of it kind of gives it away, right? Z-score chart. How do I make this? I'll make this into a z-score. Yay. How do you make this into a z-score?
Subtract that from.
Yeah, it'll be the data point minus the mean.
And divide standard deviation.
We'll have a standard deviation. So it'll be 27.2. That's the data point I'm interested in. Always minus the mean. They never switch places. If my data point's below, it better come out negative. Don't try to force it to be positive, then you're on the wrong side of things. Wrong answers. Shit. Bad. 27.2 minus what? 31.64. That's the mean. Divided by 7.81, because that's the standard deviation. I like it. I like it. No C shit. And what do you get for that? Negative 0.28? I thought so. What do you guys get?
Negative 5685.
0.57 what?
5685.
Oh, 5685. So rounded to two places, of course, because the chart only goes out two places. So this is negative 0.57. So then how do I find this area below that? Look up what? Negative 0.57. I love it. I'm trying to make sure you guys are completely with me, because part of this is the nuts and bolts of this seem too easy to believe. But if I know something's normally distributed, I know a lot about it. That's why we can make this. If it's normally distributed, it must follow, it must be symmetric, perfectly symmetric. It must have certain percentages within certain areas. So that's why we can create this chart. And I know all these answers as long as I can get the right z-score and look it up. So negative 0.57, you look that up. What do you get? Negative 0.5987. There. So what you guys get? 2843?
Yeah.
So that's 0.2843. Do I subtract 1 minus that now? Hell no. Why not?
It is there.
That's the answer. I shaded the answer. Did I just find that area? Yeah, I'm done. That's why you shade the direction that it wants you to find, so you know when you're done. Some people just always do 1 minus, and now I'm like, what's your answer, Shane? Alright, so you guys do number 2 then. catch up to you. How do I set up the z-score formula? Good. My data point minus the mean divided by the standard deviation. What do you guys get for the z-score?
2.73.
2.73. 2.73?
Yeah.
Okay. Lewis, yeah, we got some dissension, yes. Oh, shit. 2.73, yeah. Okay, cool. Because it's 2.734, so round it to 2.73. You look that up in the chart, 2.73, 0.9968, so almost 100%. Down here, right? You immediately put whatever you looked up down there. Don't think about your question, don't think about anything. The minute you look up a z-score, put the area below it. And then you step back and go, oh shit, that's not my answer. How do you get your answer? Yeah, 1 minus that. You want the rest on the other side. So 0.0032. I like that. So if this data was correct, which it probably isn't, because I just made it up for this practice thing, it would almost be impossible to find a gross fund student who takes more than 53 minutes per week. You know, adding up how much time. How long does who parks on campus? Anybody? How long do you think it would take you each time you come to campus to find a spot?
Getting a semester now.
Oh yeah, good point.
Yeah.
Now, right now.
5 minutes.
Yeah, it depends on what time of day you come.
Depends on which
All right,
one.
you come in here about 7:52. Forget it. I'm just trying to get on campus. You come in here about 10, and that probably sucks for trying to find a spot, right? You come in here about 5 p.m. and it's like, oh, it's everything. You're like, what's your problem? Everything's great. All right, I like it. So I don't know. So if it's like 5-10 minutes per day, and if you came to campus 5 days a week, then my mean is a little bit low. So all right. I just didn't know where you guys were. Me, it doesn't take me a long time. Most days. Probably because I get here at 6:30. So what do I have to do for this guy here for part 3? The mean is still 31.64, so 15.5 and 19.5 are like down here. I want the area between them. So now, do you guys realize now that it's a multi-step problem? And it basically goes like this. It's if I give you an X score, you have to make it into a Z score, and then you got to look that percentage up. So this is the formula, and this is the chart. Does that make sense when I write that? Okay. So if I give you an X score, you convert it to a Z score through the formula, and then you look it up in the chart. And if I give you a percentage, you look it up in the chart, and then you can convert it back to an X score. We're going to do that kind of problem here very soon. So it's just basically you go, if you start here, you go that way. If you start here, you go that way. It's crazy. All right. So here, I got to make Z scores out of both of these. So I need a Z score for 15.5, and I need a Z score for 19.5. Here's what I get from those. I get 2.7, oh I'm sorry, negative 2.07 and negative 1.55. This is negative 2.07. This is negative 1.55. Be really, really careful. Truly round it. Don't just cut it off. If it's 0.66666, make it 0.67. Don't cut it to be 0.66. you will lose points. Or maybe a point, really. Just be careful. Now, what do I do? Subtract these? Now I gotta look up the percentage. I gotta look up the area. I appreciate the enthusiasm. Now's the time to make a mistake because it doesn't mean anything yet. Points don't matter. So negative 2.07. I get 0.0192. Did I do that right? Yes. 0.0192. That's going to be here. 0.0192. Now what's below the negative 1.55? 0606. I like it. Captain, my captain. 0606. So now to find the area between, I just subtract them. Again, that makes complete physical sense. You gotta love that when that happens in math. 0.0606 minus 0.0192 is something or other. I don't know. 14? Sure. Oh crap. 0414. So about a 4.14% chance that somebody would take between 15 and a half and 19 and a half minutes. Now, right now, we're at the nuts and bolts, learning how to do things level. So I would love it if somebody's out there going, why the hell would somebody want to know that shit?
Why would they want to know this?
Yeah, why would they want to know the probability it takes somebody between 15 and a half and 19 and a half minutes to find the parking spot? Alright, so I could ask questions like that one. Like if it takes longer than an hour average per week, maybe that's pointing to a need for something to happen. The traffic patterns to change or something. Certain times of the day, I'm like, no, I'll just sit in my office for a while and wait for all the crap to clear out. Right? And you guys might know what I mean. You leave around 2, forget it. Right? Okay, so some of these questions might seem like what's the purpose, but right now the purpose is purely to get used to how to do this. Convert to z-scores, look them up, it's just the mechanics we're trying to get to know. So what about this into the 14th percentile? So where would I draw that? Yeah, down here because it's supposed to have just 0.14 below it. I like it. So I can look up the z-score, but then I need, what I want is a time. I really want this to make sense. What are the units of z-scores? What units do z-scores have? I like it. If they would have anything, it would be that. But actually, to be honest, it's just the pure number of standard deviation, so it's not even a unit. If they were, here, what are the units on the raw scores? Raw scores being like, they're all minutes, right? You guys with me? So, but when I calculate a z-score, it's minutes minus minutes. Well, that's minutes. Divided by minutes, the minutes cancel. No units, right? No units. So, when I look up the z-score here, that's not going to be my answer because it has no units. My units on this has to be minutes. I want a maximum time. So let's first see if you guys can find the z-score for 0.14. And just realize you know which side you're looking on, right? Don't go into it blind going, I don't see anything on the negative side, because it's on the negative side. 0.14. It's not 0.014. 0.14. Hey, that's the closest I can get is right there. You guys see that? 0.1401? It's very often you won't get exactly the number, but just get as close as you can. And what z-score is that? Negative 1.08. I like it. Negative 1.08. Now, I need to convert that into an x score. That is a z-score. I think we've done this before. Believe it or not. We solved this for x. Multiply by sigma, and then add the mean. That is my formula for if I know the z-score, I can convert it back to an x score. It's the same formula, it's just written in a better form. This should be on your old formula sheet, right? I mean, we've done this formula before. So you multiply it by the sigma, that's where z sigma comes from, and then you add the mean, that's where the plus the mean comes from. And what's the z-score tell you? The number of these away from the mean to a data point. Holy shit. It's a sentence that tells you the answer to a question that I'm going to have on every single test. And never in the history of teaching stats have I gotten less than 4 people getting it wrong. Normally it's about 10 or 12. I'm going to cry tears. I don't know. I tell you the answer. And I even tell you it's going to be on your formula sheet. The answer is going to be sitting right there on your formula sheet. Maybe someday. All right. So how do I use this damn thing? What do I know? Do I know anything? No. I know the z-score. We just figured it out, right? Negative 1.08. I know the standard deviation, right? What's the standard deviation size? 7.81. And what's the mean? So it's actually minus, right? Plus and negative is minus. Are you guys with me? Cool. So if we do 31.64 and go down 1.08 of these, start at 31.64, go down 1.08 of these,